presenter is Liang Gao, Assistant Professor of Bioengineering.
Hi everyone, my name is Liang Gao. Today I will introduce our revolutionary high-resolution real-time flash imaging LiDAR systems. I want to start my pitch from these tragic stories recently happened in Arizona. A Uber self-driving car hit and killed pedestrians on a city road. And this story quickly became head news on many news outlets. And Uber had been widely criticized for the rush move in autonomous driving. One of the key factors for this accident is a spinning LiDAR on this car failed to recognize the pedestrian. We cannot afford such a tragedy to happen again. And there is unmet need to develop advanced imaging LiDAR systems to push the safety of autonomous driving to the next level. Beyond autonomous driving, LiDARs also have numerous applications in other fields, such as robotics and remote sensing. In the US market alone, the market size has reached $1.1 billion in the year 2020, and this number is expected to grow to $2.8 billion in the year 2025. There are two types of the LiDAR systems currently deployed on self-driving cars. The first type is called spinning LiDAR. Spinning LiDAR scans laser beam in the circumferential manners and measure the time-of-flight signals or reflect signals. But the drawback is that it only has very few lines along the vertical resolutions, along the vertical directions, resulting in a very low vertical resolution. So this type of LiDAR cannot be used to recognize the different targets. For example, we cannot tell apart our pedestrians from large animals. By contrast, imaging LiDAR can provide much higher resolution. By using these scanning mirrors to perform this two-dimensional raster scan. But to acquire high resolution like this one is very time-consuming, so it cannot be applied for this real-time autonomous driving, where timing is critically important for this decision-making. To address this problem, our solution is to acquire these 3D scenes by a single snapshot. This is different from these conventional 1.0 technologies, which rely on scanning. Our technology, which we call 2.0 tech, is based on this published work, light field tomography, which is built upon these computational imaging architectures. A key feature of this 2.0 tech is that we can acquire these three-dimensional scenes by a single snapshot without using any scanning mechanisms. This is real-time flash imaging LiDAR demo using our system. We image these dynamic scenes in our lab. You can see when we rotate this middle ladder at high speed, our camera can recover these 3D motions with very high fidelities. I want to emphasize, such a video cannot be recorded using conventional 1.0 scanning-based LiDARs, because otherwise it will introduce severe motion artifacts. Compared with scanning-based systems, our 2.0 tech offers several few key advantages. For example, it's the first LiDAR system can provide this HD resolution at 30 frames per second, and also has zero moving parts, so it's super durable. And for mass production, we expect the cost of the whole system will be less than $200. Although our imaging LiDAR system can be applied for many different applications, our niche effort will be focused on autonomous driving. Our business model is to partner with a major car manufacturer and develop these customer HD imaging LiDAR systems for the self-driving cars. There are several major players in this field, but you can say all their LiDAR technology are based on this scanning-based 1.0 tech, and they have provided very limited vertical resolution and field of view. By contrast, our technology is the only technology that's based on the 2.0 snapshot acquisition and provide unprecedented vertical resolutions and field of view. Regarding timeline, we already have research prototype running in the lab, and currently we are building an engineering prototype and expect to finish it by the end of the summer. And we expect to have MVP by the end of this year. I'm the founder of these companies. I have over 15 years experience in developing optical imaging hardwares as well as LiDAR systems. Currently, we are looking for $1 million seed grant for developing the MVP. We are also looking for advisors to join our team, and we are also open to the collaborations and partnerships. Okay, everyone, who want to be a partner with us and build the next generation imaging LiDAR systems to push the safety of autonomous driving to the next level. Thanks again for your patience. And if you have any questions, I can be reached at this email. Thanks.